As this US-flagged tanker neared safety, it became easier for an Iranian missile to hit. That sounds backwards. Out in the open sea, a tanker is exposed. It is slow, it is huge, it cannot turn like a destroyer, but at least the ocean gives it room. Room to change course, room for escorts to spread out, room for radar crews to see what is coming. Then Sea Isle City approached Kuwait, and the rules changed. This was not just a ship moving through water anymore. It was a massive floating target entering a narrow system. To reach the oil port, it had to slow down. It had to follow a predictable route. It had to stay inside safe water. It could not zigzag. It could not make a sudden hard turn, and it could not simply run away. For a commercial tanker, the closer you get to port, the less freedom you have. That is the trap, because a missile does not need the whole ocean. It only needs a target that is big, slow, and easy to read. And near a busy port, everything becomes more complicated. Civilian ships crowd the water. Radar screens fill with clutter. Buildings, cranes, coastline, and other vessels create confusion. Defenders have to identify the threat. They have to confirm its path. They have to avoid hitting the wrong target. And they have to do it in seconds. So the place that looked safer on a map became more dangerous in physics. This is the hidden weakness of a port approach. It turns open water into a funnel, it turns a moving ship into a predictable path, and it turns an old anti-ship missile into a far more dangerous weapon. But here is the most important part. The missile did not have to sink the tanker. It only had to strike the right section. The bridge, the controls, the radar, the communications, the part of the ship that sees, decides, and gives orders.
So why does a tanker become easier to hit the moment it gets closer to port?
Understand that. Do not start with the missile. Start with the geometry of Kuwait's harbor. Start with the geometry. Out in open water, a tanker is still vulnerable. It is large, it is slow, carries momentum like a moving island. But it has one thing that matters: space. Space buys time. Time lets escorts spread out. Time lets radar crews study a track. Time lets a captain adjust course early. No one is saying a tanker can dodge a missile like a fighter jet. It cannot. But in open water, the defensive system has room to breathe. A strange contact appears on radar. A patrol aircraft can look closer. A warship can shift position. The tanker can change course before the danger closes in. Even a small course change matters because distance turns seconds into minutes, and minutes can save a ship. Now move that same tanker toward Kuwait. Everything begins to shrink. The ocean no longer feels open. The ship is not just crossing water anymore. It is entering a controlled approach. There are safe channels, there are shallow zones, there are other vessels, there are port procedures, there are turning limits, and there is a massive hull that cannot stop quickly. This is where the trap begins. A tanker approaching port cannot simply go anywhere. It must stay where the water is deep enough. It must avoid other ships. It must maintain a stable approach. It must slow down. It must become predictable. Outside the harbor, the ocean is a wide sheet of water. Near the port becomes a hallway, and Sea Isle City was entering that hallway. Think about the size of a tanker. It does not respond instantly. When the rudder turns, the ship does not snap sideways. It leans into a slow, heavy arc. The bow begins to shift. The stern follows later. The whole ship carries forward momentum. That means every decision takes distance. Every correction takes time. And near a port, both are limited, so the captain does not have open sea freedom. He has a route. He has traffic. He has depth limits. He has safety rules. And he has a ship that needs space to maneuver. That is the first technical problem. The closer the tanker gets to port, the more its path is shaped by the environment. Then comes the second problem: speed. A tanker at sea can maintain a steady cruising speed, but near port it has to slow. That sounds safer. But for a missile engagement, slow speed can be dangerous. A slow target is easier to read. Its future position is easier to estimate. Its turn rate is limited. Its movement becomes less random. If the target cannot accelerate, it cannot escape the channel. Oh, how much does the missile need to guess? This is not magic. It is physics. A large, slow ship creates a cleaner tracking problem. Path changes gradually. Its silhouette stays huge. Its radar return stays strong. And near port, it is moving through a smaller box. That box becomes the funnel. But the route matters even more. A tanker cannot zigzag through a harbor approach. It cannot cut across shallow water. It cannot ignore the traffic lane. It cannot swing wide whenever it wants. The ship must follow the safe approach toward the terminal. That means an attacker does not need to search the entire Gulf. The focus can narrow to the places the ship must pass through. The waterway does part of the targeting work. That is the ugly truth of port geometry. It turns choice into prediction. It turns prediction into vulnerability. And it turns vulnerability into opportunity. But there is another problem most people miss. A busy port does not always make defense easier. It can make it harder. More ships mean more radar contacts. More coastlines mean more background clutter. Cranes, buildings, anchored vessels, patrol boats, and commercial traffic all fill the picture. A radar screen near a port is not empty. It is crowded. And when the screen is crowded, classification becomes harder. What is a normal vessel? What is a threat? What is a false track? What is a missile flying low over water? Defenders cannot just react to every contact. They have to identify the right one. They have to understand its path. They have to decide if it is hostile. Then they have to act before the window closes. That window can be brutally short, especially if the threat is flying low. Low over water, a missile can hide behind the radar horizon longer. It can appear late. It can compress reaction time. When it appears near a civilian port, every decision becomes heavier. A warship in open water can engage with fewer outside risks. Near a harbor, the background is full of people, ships, and infrastructure. A wrong decision can hit the wrong target. A late decision can let the missile through. So the defender faces a cruel problem. Wait too long and the tanker is hit. Act too fast, and you may strike the wrong object. This is why port defense is not just about weapons. It is about timing. It is about identification. It is knowing what is moving, where it is going, and how many seconds remain. Sea Isle City was not just a tanker near Kuwait. It was a huge, slow, predictable target moving through a crowded approach. Each layer made the next layer worse. The channel limited movement. Low speed reduced escape options. Traffic complicated detection. The harbor compressed decision time. And the missile only needed one clean path. This is why the safest looking place can become dangerous. On a map, a port looks protected. In physics, it can be a funnel. Once a massive tanker enters that funnel, it is easier to track, harder to defend, slower to save. But the most frightening part is not that a missile could sink the ship. The frightening part is that it did not have to. That is the real twist. A missile does not need to split a tanker in half. It does not need to send the whole ship underwater. It only needs to kill the mission. This is called a mission kill. The ship may still float, the hull may still hold, the cargo may not explode. But if the ship cannot steer, communicate, navigate, or continue safely, the mission is over. The tanker is alive, but useless. And near a port, that can be enough. Because a tanker is not a speedboat. It cannot slam the brakes. It cannot whip around. It cannot drift safely through crowded water with damaged controls. Once the ship loses command, everything around it becomes a threat. The channel, the coastline, the other vessels, the shallow water, even its own momentum. So where is the real target? Not always the thickest steel, not always the biggest fuel tank. Sometimes the real target is the bridge. The bridge is the ship's brain. It is where the crew sees the water. It is where the ship is steered. It is where navigation is checked. It is where orders become mechanical action. Around that upper structure are systems that matter. Radios, radar displays, navigation equipment, windows, watch stations, control links. People damage that area and the tanker may still float. But now it cannot think clearly. It cannot see clearly. It cannot respond quickly. That is why mission kill is so dangerous. It changes the goal of the weapon. The missile does not need to destroy the ship. It only needs to hit the part that lets the ship operate. A tanker can be hundreds of meters long. It can carry a massive load. Its hull can absorb damage, but the part that commands movement is much smaller. The ship's body is huge. Its decision center is not. And when that decision center is damaged near a harbor, the danger multiplies. Because now the ship is still moving, but the crew may have less control. It is still surrounded by traffic, but less able to avoid it. This is how a missile can create chaos without sinking anything. It can turn a working vessel into a drifting problem, and that is enough to stop the voyage. But why does an anti-ship missile fit this environment so well? Because it is designed to deal with large objects on the sea. A tanker gives it a huge shape, it gives it a steady path, it gives it slow movement, and near port, it gives it less room to maneuver. The missile is not solving a wild puzzle, it is solving a cleaner one. Large target, slow speed, limited route, crowded background, short reaction time. That is the geometry. The more predictable the ship becomes, the simpler the engagement becomes. This is not because the missile is magical. It is because the environment is doing half the work. The port approach forces the tanker into a narrow pattern. The low speed makes its future position easier to estimate. The shallow water limits where it can go. The traffic lane limits how it can turn. And the surrounding port makes defense more complicated. So the missile does not need perfection. It needs opportunity. And Kuwait's port approach created exactly that. Now here's the second twist. Why not just shoot it down? But near a busy harbor, nothing is simple. First, defenders have to detect the threat. If it is flying low over water, it may appear late. Then they have to classify it. Is it really a missile? Is it a false track? Is it clutter from the coast? Is it another aircraft? Is it a civilian contact? Then they have to confirm the direction. What is it heading toward? How fast is it closing? How many seconds are left? After that comes the hardest part. They have to decide. A wrong call can be disastrous. Fire too late, and the tanker gets hit. Fire too early, and you risk the wrong target. Near open water, the picture can be cleaner. Near a port, the picture is crowded. Ships are moving. Structures reflect signals. Coastlines create clutter. Civilian vessels fill the area. Every defensive choice carries baggage. This is why defense is not just firepower. It is recognition, it is timing, it is judgment under pressure. And pressure rises when the target is close to land. The old question is, can the missile sink the ship? But the better question is, can the missile force the whole system to react? Because that is where cost becomes brutal. A tanker under a US flag is not just steel. It is cargo, crew, insurance, escort planning, port scheduling, repair time, security procedures, and the warships protecting it are not cheap either. They need fuel, crews, sensors, helicopters, command links, and maintenance. Every convoy requires coordination. Every escort burns money and attention. One anti-ship missile does not need to defeat the entire US Navy. It does not need to win a sea battle. It only needs to damage one vulnerable moment. It only needs to stop one ship. It only needs to force the escort system to change. That is the cost paradox. A weapon does not need to destroy a system. It only needs to make the system respond at a much higher cost. And that is why the Sea Isle City case matters. The tanker was huge, its speed was low, its route was predictable, its maneuvering space was narrow, and the defense picture was crowded by the port itself. Put those together, and the map changes. The harbor is no longer just a destination. It becomes a machine that compresses options, a machine that reduces time, a machine that turns a massive ship into a readable target. That is the real meaning of the death funnel. It is not just geography. It is geometry, speed, inertia, and civilian clutter working together. So the most frightening lesson from Sea Isle City is not that a missile arrived. It is that the tanker entered the exact place where that missile became most dangerous. So Sea Isle City was not just a tanker hit by a missile. It was a lesson in how safety can turn into exposure. On a chart, a port looks protected. It has traffic control, escort plans, and friendly waters. But in physics, that same port can become a funnel. The ship slows down. The channel narrows. The route becomes predictable. The room to maneuver disappears. And defenders have less time to understand what is real. That is the hidden danger. The threat was not only the missile. It was the environment that made the missile more effective. An anti-ship weapon does not always need to sink a ship. It can hit the bridge. It can damage navigation. It can break communications. It can injure the crew. It can force the voyage to stop. And once that happens, the cost spreads far beyond the hole in the steel. Escorts change procedure. Schedules break. Insurance rises. Crews adapt. Every future approach becomes more tense. That is why every harbor approach becomes a technical problem. In modern naval warfare, safe on a map does not always mean safe in engineering. Sometimes, the most dangerous moment comes when the mission looks almost finished. If one oil port can become a trap, the next question is harder. How do modern fleets protect maritime choke points without turning their own routes into predictable targets?
Shot right to follow is not immediately the breakdown.